Okay, so welcome back. So we'll continue our discussion on the ecosystems as we've been doing in this particular set of videos. So we were talking about ecological successions. So it's a basically we are looking at the change in the community in which the new population of organisms gradually replaces the existing one. That's what the succession is, isn't it? So one after the another. So there are actually two types of succession which we'll talk about. One is the primary succession and the second one is the secondary succession. And so let's look at that one by one. So in terms of primary succession, what we're talking about is there is essentially it happens when there is no soil. So if you have a volcanic eruptions or a glacial retreat in those areas, life is not possible. So it's unfavorable at first. So you don't have much of the life forms available at that particular time. But then you will see that gradually things will start coming up. So you will have a simple plants coming first. Then you will have gradual influx when the simple plants comes and they matures, and then you will have other species kind of coming on that. Then it basically ends up in a good ecosystem, provided there is no influence in abiotic factors. So if there is abiotic factors are favorable, so you will have, we already talked about abiotic and biotic factors. So if you have there is nothing very negative from the abiotic factors, so you will see that it will eventually develop into a good ecosystem. For example, from rock to moss, moss to ferns, ferns to grasses, grasses to herbs, herbs to bushes, then trees, and now the climax forests. So this is your primary succession, like gradually from one after the another. This is how the ecosystem develops. So that's called primary succession from the very beginning, from the simple plant all the way to the matured forest. So in terms of secondary, where in this case there is certain community development in the areas where there was previously occupied by other community, but then some disaster happens. Say we have a forest fire, for example, recently we had this bushfire in Australia, or some natural disaster somewhere else. So after that disaster is over, but the disaster actually destroyed a lot of species. Now the newer community will start building in. So that's occurs after disaster like forest fires or deforestation and all. And once the disaster is over, then the favorable conditions develops for certain types of species. So those species started coming in, and then there is a rapid development, and then you see that the whole ecosystem has kind of changed a little bit in terms of your secondary succession. So that's on but those two are kind of not that common. What you see, like it's a kind of it's a once in a say like a few hundred years kind of event, or maybe some thousand years event, when you see those kind of things happening. What in general, when we talk about the ecosystem as we kind of know today, the things try to stay in balance. So that's what it is, the homeostasis what we talk about. It's a kind of things are in your balance. It's a equilibrium of the organisms in the ecosystem. So things are staying more in it's a more stable state ecosystem. The population of a species lies within a similar range. So that's what you see. There is some shift, as you can see on this picture over there. If there is a shift, the other will try to bring it back to stay in equilibrium. So for any shift in the equilibrium, ecosystem tries to regulate it. So, and we'll look at it in an example and try to explain that. So for example, in the grassland system that we have looked at, we have a large amount of grassland. So you can see the lush green grassland over there. So we have some animals, they're eating it, and since a lot of food is available, so they grow, they produce, they bring more increase in population. Like you will have more grasshoppers, more cattle coming due to access of food available. Now when you have access of initially you had access of food, you have lots of grasshoppers, you have lots of cattle and other stuff. So what will happen gradually? If you eat up all if you eat up all the food, so there will be reduction in the grassland. So that's what we were talking about earlier. If you remember, we were talking about that ecological balance, or that ecological footprint, or ecological depth, or even the concept of that earth overshoot days. So that if you use up all the resources, then you have now reduction in grassland. So these animals will start starving, as you can see from the pictures. Now even their like bones and other stuffs are is visible if you look closely in that particular photographs. So Now, what that will lead to the death, that will lead to the starvation. Population of a species decreases due to starvation, so there will be a lot of death, and now the population has gone down. So, what will happen? Now, then again your grass will again come back. So, grass will starts growing back because due to less consumption, and since it is a less consumption, things will come back again, and then again the cycle will continue. So, that is what, so the nature, we say that mother nature balances itself. So, that is what we are talking about here. It is a balance of the ecosystem which is taking place in, this is just a simple example of how things work. So, there is a when we talk about these ecosystem, and when we talk about nature, and we talk about resources, as an engineer and the professional, we talk about the resources. There is a concept of this natural capital, which when we talk about all these economical activities, like all those, when you start relating these to GDPs and all those kind of stuff. So, it's a natural means provided by the ecosystem, functions and components. Capital is form of wealth to create more wealth. So, that is what all these resources, biotic and abiotic resources, renewable and non-renewable resources. Now, we are getting into all those jargons. So, capital is your form of wealth to create, to make more wealth. So, the natural capital is actually an environmental wealth to make more wealth. So, you have the environmental wealth to create more wealth. That is the concept of the natural capital. If you talk to an environmentalist, they would say a natural capital instead of natural resource. So, in general, we talk about natural resource, isn't it? We talk about natural resource. Now, there are two types of natural capital or natural resource. We have the renewable and one is non-renewable. So, renewable natural capital is your living and non-living things, which is replenishable, which gets created again and again. So, that is your replenishable. It is you can bring it, and living and non-living both, which is can be replenished. Non-renewable is natural capital, is essentially the mineral resources. You may hear me many times talking about whenever we talk about these mineral resources, especially non-renewable stuff, I give the example of the periodic table. So, most of the stuff on the periodic table, almost all the stuff on the periodic table, we cannot create, we cannot destroy. As humans, we cannot create, we cannot destroy. We can only change its form from one form to another form. So, that is what we can do. So, this renewable natural capital may be depletable by the over usage as well. So, one is the non-renewable, which of course, we are depleting. Now, renewable natural capital can also be depletable by the over usage. So, rate of consumption is much higher than rate of reformation. That was the earth overshoot day, if you remember, when we are discussing that like a few videos back on in the class as well. So, this earth overshoot days was the where rate of consumption was much higher than the rate of reformation. So, reformation. So, again the formation of that natural capital. So, that is kind of leading to even the decrease in the renewable natural capital. So, natural capital, what they provides natural income, the annual yields of goods and services. They provide water, they provide food, medicines, paper and whatnot, oxygen production, soil stability, recreation, aesthetics, and all those kind of stuff. So, if you look at the natural income is your annual yields of goods and services. So, that is your entire annual yields of goods and services, that is your natural capital for that natural income for that particular year from the natural capital. For example, say if you want to do harvesting of bamboo, that depends on the availability of bamboo and its quality, which is your natural capital. But harvesting also depends on the cutting machineries, which is your build and financial capital, the skill of workers, which is your human capital, and governance, like how the things are. If it's too much of unrest, if lot of unrest in the society, a lot of like agitations and other things are going on, things are not very, society there is no peace in the society, that also affects. So, that's your social capital. So, that comes under our governance. So, that's your social capital. So, these are important concepts, like if you're like biomass that you have, the bamboo, the availability of bamboo and its quality, that's the natural capital, isn't it? Then we have harvesting depends on the cutting machineries, how good are our build and financial capital, how good machineries we have, how much money we can invest to get good machineries, is skill of workers, that is the human capital. So, training of the manpower, governance, keeping things in place, that is our social capital. So, all four are important. So, as you can see in this circle within circle diagram. So, if you look at here, you have that whole natural capital, then you have social, human capital, build and financial capital, all those are important in terms of coming for our like day to day function of our ecosystem or the way that we are. So, all capital interacts for the well being of the humans. So, that's for the well being of the humans, we have all these capitals interacting with each other. So, there is a very good set of videos which I have put it link over here, and you will have this set of slides in the as part of the class. So, I would encourage you to go on this YouTube, and there is a short film series on natural capital. So, that will give you more idea about that. These are quite I think these are for many of you, these might be a very different type of class after preparing for GEP for almost 4 years or so and going through all those physics, chemistry and all those stuff. Those are great stuff, I am not saying, but this is what we are talking in this class is basically what you will be talking in different type, you may be talking in a different language, but essentially these are the kind of things that will come up in the discussion when you start working as a professional in any field, and because ultimately we all have to live on this planet, and we have to keep this planet nice and clean for us and for our future generation. So, let's keep moving, and I hope this is making sense to you and you are enjoying it so far and so good. So, in natural capital, if you can just delve into a little bit more detail. So, we have natural capital in terms of ecosystem structure, processes and functions. You have natural resources, which is ecosystem goods and services. You have beneficiaries, which is people's household, farmers, communities, business, industry and government. Environmental, natural, biodiversity, conservation and management and all that. So, individually if you look at these 4 sectors, they interact with each other. So, natural resources will interact with the beneficiaries, natural capital has interaction with natural resources, environmental and natural capital has interaction going on, beneficiaries again interacting, impacting environmental, natural resource and biodiversity and all that. When we talk about natural capital, we have land cover, biophysical properties, biodiversity, subsoil resources, atmospheric conditions, those are important. When we talk about natural resource, economic goods and services, provisioning service including natural resource, regulating services, cultural services, beneficiary, local, regional, global, in terms of environmental, natural resource, biodiversity, conservation and management, what are the policies, what are the regulation, stewardship. So, all those things comes in picture. So, these were conceptual framework, the provision of natural resource and ecosystem service. This was this is essentially in environmental accounts and statistics division of Statistics Canada. In 2013 they came up with this report where they kind of try to put these in these different segments, trying to explain natural capital and the ecosystem services. So, when you look at the ecosystem services, human beings benefit from ecosystem in many ways. They are known as ecosystem services. We get provisions, we get we have regulating stuff, supporting stuff, as well as the cultural stuff from the ecosystem. So, let's move it over there. So, provisioning service is it's what are those in the earlier slides what we looked into. Let's look at it some more detail. Provisioning services, the products that are all directly used by human beings, which is food like crops, wild plants, etc., animals and their outputs. Then we have water like timber, medicinal plants, fibers, energy is your biomass for energy and all that. So, we use food, we use water, we use materials, we use energy. Those are all the provisions we are getting it from the mother nature. Then regulating, what is the regulating? They do take care of mediation of waste and toxics, the natural remediation, filtration, accumulation, erosion control, water flow maintenance, maintaining of natural processes, climate control, disease control, many of the things that mother nature does by itself in terms of self correction and all that, that comes into regulates the environmental media and processes which happens in the ecosystem. Now, nutrient cycle, oxygen production, those are our supporting services which supports the humans. So, they are called supporting services. Then we have cultural services, because say if you have all these waters and you have ponds for recreation, we have water bodies, we have hills, mountains, all those for recreation. We also for education, scientific value, cultural heritage. Many of the things are related with culture. Oxygen again, like a spiritual interaction, going to forest, meditation and all that. So, all those your cultural services. So, if you look at the ecosystem, there are like we have so much of interaction, we are actually part of the ecosystem. So, we have there is like we cannot take us out of the ecosystem. So, we have to be, we are also one of the integral part of the ecosystem. But again, as I said in the very beginning of this course, we are only one of the component of the ecosystem. Ecosystem will be there without us. We cannot be there without this ecosystem. So, that is very, very important. So, in terms of ecosystem services, if you look at some more things in detail, let's we have so we have institutional and human judgments determine the use of service, the economics of ecosystem and biodiversity, feedback between value perception. So, there is one concept like a human well-being, like socio-cultural context, so benefits and the economic value. Then we also have management and restoration in terms of ecosystem and biodiversity. We look at the vegetation cover, we also look at the function in terms of slow water passages like biomass production. We also look at the services in terms of food protection, protection, flood protection, sorry, and products that is coming up. So, there are different components which comes into in the form of your like a different processes which comes as part of the economics of ecosystem and biodiversity. So, this ecosystem services has been given a quantification number has been provided to that just to put things more in perspective, because as I said earlier, we engineers and professional, we always try to have a number so that we can start doing some number crunching and making some of the sense out of all this information that we have been discussing in this particular topic for last 2 videos, and this is the third one. So, in terms of ecosystem, so how to quantify these ecosystem services and how to relate it to our overall development, sustainable development, gross domestic product and all that. So, this using gross ecosystem product, it's basically to value the nature. So, how to incorporate nature into decision making. So, when we talk about this economic development, we always talk about like GDP. Now, the GDP is great, but in terms of like when you only look at the products and other stuff, but you do not take care of your environment, you do not take care of the ecosystem for which you need those ecosystem to be part of to kind of survive on a long term basis. So, we try to value the ecosystem services in a single monetary unit, which was developed actually very recently this year itself. The paper came out where they come up with this gross ecosystem model. So, this GEP, where it's a gross ecosystem gross ecosystem product. So, like we can say gross domestic product. Similarly, we have the gross ecosystem product, GEP now, not GDP, where so here we have YI is the proportion of accounting value attributable to nature, P is the accounting price of the ecosystem service, Q is the quantity provided by the ecosystem service. So, and I is the set of ecosystem services. So, there are you can have I varies from 1 to n, and then Y is your proportion of accounting value. So, how much accounting value attributable to the nature. P is the accounting price. So, how much like a price for that particular service I. Q is your quantity provided of that particular service I. So, that is to multiply these 3 and then add them up all together. So, that gives you the gross ecosystem product. So, for regulating ecosystem services, the entire value of services attributable to nature. So, Y will be equal to 1. So, for other services including many material services, there is a contribution from human labor and human made inputs. So, for that Y will be less than 1. So, GEP provides a significant evidence of monetary value of ecosystem services for decision makers. So, when you talk about GDP, it's you need to look at the GEP as well. That's what, and then you need to see that your gross economic, like a gross ecosystem product is how much value you are getting out of the ecosystem. So, then we will realize why to save this ecosystem, why to keep our environment clean, so that we kind of put a monetary value to it, so that we can try to quantify the damage like loss that we are doing in terms of if we are not taking care of the environment, the ecosystem around us. So, this is again in terms of ecosystem service, the ecosystem assets like forest, wetlands, grassland, etc., plants, wildlife, those are put into, like we have this. So, in terms of ecosystem assets, we can look at gross ecosystem product, which we just looked at in the previous slide. So, we look at the ecosystem service, material, regulating, non-material, then we come up with this decision environment, where you look at the evaluation of government policy and performance, how government policy and performance is going to help us in terms of keeping this ecosystem healthy. Then land use infrastructure planning, financial compensation for ecosystem service suppliers. Then do you make some decision, you apply those, decision, implement those, protection, restoration, compensation, sustainable management, and then you look at your ecosystem again. So, it kind of have this cycle going on, where you try to preserve a healthy ecosystem. So, the relationship between ecosystem assets, gross ecosystem product, and decision making, this was done by Zion et al. It's very recent paper. They used ecosystem product to value nature in decision making. This was come in the proceedings of National Academy of Sciences in June 2020. So, it is a newer concept, but it is an important concept where we are trying to look at gross ecosystem product as well. Now, in terms of ecosystem services, whenever we talk about ecosystem, what are the risks associated with that, since we talked about all these potential contamination and then human impact and all that. So, there is a risk assessment from human action, what are the chemical emissions or management actions. So, those we can look at in terms of impact. Then what kind of ecosystem is stressors or condition. Then we will have a response function in terms of how does the ecological outcome, so how it reacted. Then what ecosystem services could got affected. So, the entire these 4 steps together is kind of what constitutes a risk assessment for this ecosystem service, and then whatever is the risk is there, we have to manage that risk. So, that is we have to do the risk management and look at the societal benefit. So, this was again this framework was developed almost 10 years ago, which is to assess the risk of chemical exposure resulting from change in human action of ecosystem services and societal benefits. So, that is your ecosystem services we look at. Now, if you put it in a broader concept in terms of globalization or global concept. So, this violation of biogeochemical cycle in the second half of the 20th century, after this second world war with industrialization and like lot of demand for resources, lot of industrial activity and all that, and other things associated with it, we did create a lot of problems. And major problem, as we know today, which we have discussed earlier also in the class, and we will be discussing in different context in later on also in this class, is the climate change due to greenhouse effect, decrease of biodiversity, desertification, etc., because of different conditions. So, those those are the effects. So, we have to look at some of these questions that we need to address in terms of major questions resulting from studies of global biological process, like what biological, physical, biological, chemical and social process regulates nutrient cycle. So, how our nutrient, because those nutrient carbon, nitrogen, phosphorus, sulfur, phosphate, they are those are very, very important for different ecosystem functioning. So, what physical, biological, chemical, social process is regulating those nutrient cycle. What are the anthropogenic interferences with the nutrient cycle, like how what are our anthropogenic activity which is affecting nutrient cycle, and what mechanism control the ability of ecosystem to rapidly restore themselves. So, what are those mechanisms? So, how to actually get back to a scenario where these ecosystems are self-restorative as quickly as possible. So, in terms of physical, biological, chemical, social process, if you look at the individual question that we raised in the previous slide, for the first question, again there are several such questions. Can we have some mathematical relationship? Because whenever we try to quantify something, we need some mathematical relationship. Mathematical relationship requires a lot of model development. So, we have to have mathematical relationship required for modeling. Then how a dependency, we have to understand the dependency between biodiversity, ecosystem, nutrient cycle, transport process of salts and pollutants in space and time, any interrelation between these nutrient cycles. So, those are some of the questions we need to answer, so that we can answer the question highlighted in red over here, which was like a bigger question, and then these are the sub questions associated with that. Many of those questions actually will not be addressed in this particular course, because that's not the like a mandate of this course. This course is, again, as I said in the very beginning, this course is to basically make you aware of the environmental issues. We will not actually solve entire environmental issues, and we cannot provide you the tools to kind of go over for each and every questions out there, but that will basically takes almost, we need 4 or 5 courses to do that. So, that is why we have environmental electives on several electives offered from civil engineering department, from some other departments as well, which relates to many of these aspects. So, that is where you get those more detailed answer, but we will try to have some discussion in the class, so that you know where to find the answer. That is what I said in the beginning, isn't it? So, we will provide you tools so that you can go and look up for the answers whenever you need to find those answers. So, you are not totally like something comes to you, you should be aware like the context. So, that is what we have been trying to do. So, in the second question, which was there, what are the forms and ways for anthropogenic interference? Okay, so what is the human interference? Like, what are the different human activity on the which affects nutrient cycle? How land use is changed, because of the change in the way we have been our population increase, agricultural requirement, as well as industrial activity has led to many land use changes. So, what is the impact of that on nutrient cycle? What is the influence of anthropogenic pollutions on nutrient cycle? So, all these things need to be studied. That will help you answer that question number 2. And then what mechanisms controls the ability of the ecosystem to rapidly restore themselves? There we have to look at the basic parameters and characteristics of the ecosystem, which is restore after anthropogenic forcing, because of all those human made emissions and all that. Introduction of new species or disease affects the development of also nutrient cycle. What are the critical factors between ecosystems and climates? So, that right now the center of attention is the global CO2 nutrient cycle, because of the climate change and CO2 emissions and all. So, if you look at the atmospheric emissions, we had an increase of atmospheric CO2 is increased by 100 ppm for the last 200 years. So, if in the last 200 years, we had gone from say from almost from around 200 to 400 in last 200 years. So, that is like more than 100 ppm increase in last 200 years in terms of so that's what, and CO2 increase is leading, that is the major reason for the climate change, global warming and all that. So, major source of what is the where the CO2 is coming from. So, if you look at in terms of let me roll of okay, let us keep it up. So, in terms of major source of atmospheric CO2, the measures, if you look at the different countries, EU 28 countries, EU, Europe excluding EU 28, then US is one of the major contributor, but then it is actually kind of going down a little bit. India is increasing, China again is increasing. Those we have not contributed much, still we contribute much less compared to if you look at the like North America, especially US, but we have our numbers are increasing as well, and Oceania, Asia excluding China and India. So, as you can see up to say up to 1900 or 1950, this atmospheric CO2, annual CO2 emissions was much less. In last say 60-70 years, we had a huge increase in atmospheric CO2 increase. So, that is what is creating a lot of imbalances in the atmosphere, which needs to be fixed. So, if there is a like if you look at the different scenarios, if there is no climate policies, if we don't do anything, we are looking at a increase of 4 to 4.8 degrees centigrade. So, if countries had not implemented climate reduction policies. Now, based on pledges and targets, we are looking at around 2.5 to 2.8 degrees centigrade, and we have to kind of bring it down to less than 2 degrees centigrade to 1.5 degrees centigrade. So, increase these are the potential increase in the temperature. So, each pathway comes with uncertainty, marks from low to high. The warning refers to the expected global temperature rise by 2100 relative to the pre-industrial temperature. So, if you look at from by 2100, so if we don't do anything, we are looking at like quite a bit like almost close to maybe 4 to 5 degrees centigrade increase in temperature, and that will lead to a lot of like sea level rise and all the issues associated with that. So, those are the issues that we will be kind of talking about that quite a few times in this particular course. So, these greenhouse gases, they stay in atmosphere for quite long time. So, carbon dioxide, for example, 3 to 5 years, nitrogen peroxide for 100 to 120 years, nitrogen dioxide 5 days, and carbon monoxide 0.1 to 3 years, and the rest is mostly days except nitrogen peroxide, and then ferrons are also 50 to 70 years. So, I think we have eliminated ferrons to quite some extent. We do not have much ferrons these days in the product, but CO2 emissions still creates a lot of concern. So, in terms of structure of global carbon sources and sinks for chemical contaminant that take part in biogeochemical cycles. So, we have atmosphere, we have ecosphere, we have anthroposphere, we have lithosphere, we have hydrosphere. So, we have several source and sinks for all those different contaminant which gets released into the environment. So, we have things going into the ocean, from the ecosphere also it comes to the lithosphere, and then it goes to the anthroposphere, and then finally it kind of goes back into the atmosphere. So, in terms of emissions going out there. So, this is in impact of population growth is also there, trying to improve the living standards and profit margins. Humans continue to increase the rate of material production without little regard to the consequences. So, this lead to extensive agriculture and industrialization destruction, deforestation, extraction of minerals, and which is creating a lot of impact. And remember, we talked about that IPAT equation earlier. So, that is the reason why we want to have this sustainable development. We talked about it too earlier. Humanity has the ability to make development sustainable, to ensure that it meets the needs of the present without compromising the need of the future generation. The main problem is that people are reluctant to place limits on their desires and needs by adjusting them to natural process. We have to adjust our lifestyle with what nature can really support. So, need for sustainable development, we have to reduce the over exploitation of natural resources. So, 1 million species on track for extinction, the decline of more than 60% of the world's marine fisheries, scarcity of resource. So, food production needs to double over next 4 years at a time when almost 23% of the world's agricultural land has been degraded because of the use of all those fertilizers, insecticides and pesticides. We have actually reduced the soil quality so much that 23% of the world's agricultural land has been degraded. Nearly 2/3 of the world's population will be living in water scarce, water stressed area by 2025. So, climate change will lead to rising sea level, extinction threat to small island nations due to climate change, increase in atmospheric temperature and extreme weather events. So, we have to do the course correction and come up with optimal use of materials and energy. Again, optimization, resources should be used within its carrying capacity, rate of usage should be equal to the rate of regeneration of resource, use of systems theory or systems approach, resources should be used optimally and efficiently. So, these are some of the let me put it right here. So, here the economics is your production and resource exchange and transfer accounting and all that. This is ecology is material, energy, water, air, flora, fauna and all those. Politics, we talk about all those organization, governance, laws, justice, and these are your culture, engagement and all that. So, this is your in terms of sustainability, we look at different examples. So, if you look at in terms of different criteria where in terms of this economics, ecology, culture, and politics. In the ecology is kind of getting into critical area now. You can see the different colors here. The critical is the red, orange is your bad, and the light orange then highly satisfactory, then satisfactory, yellow is satisfactory, and as you go to green it becomes more vibrant. So, cultural wise, political wise, economical wise, things are more vibrant in the world, but if you look at from a ecological point of view, things are becoming more and more towards red. So, that is what we need to focus, so that because without having good ecosystem, the other three, economics, politics, and culture, cannot survive. So, again, only a collective mind, a collective will, and joint purposeful effort will make it possible to avoid disaster and open up prospects for the further development of civilization. This is a quote from Moisef in 1988. So, thank you with that quote, and I hope this set of 3 videos was kind of gave you a good overview of this ecosystem topic. Of course, now I want you to watch it before the class, as I said, and so that you are more prepared and we can have some lively discussion in the class. So, thank you and see you again.